Once again, very good morning to everybody. Without wasting much of time, once again I would like to thank the organizer for giving me this opportunity. And as I told you, I have come for God. I want to enrich my bank further, and interactions will be highly welcome. And in my talk, I have tried to provide you with three different aspects of statistical sciences. One is research methodology and the statistics. Second one is statistics, statistical tools. The third one is statistics, statistical tools, and misuse of statistics. These are the three basic things I try to develop on. And sometimes you may feel boring because I will start with the scratch, the preliminary things that of course everybody knows, or at least most of you know. So please bear with me. I try to do whatever I have learned, share those things with you. So topic is statistics in scientific methods. With special reference to applications of statistics in biological data analysis. There are key points. One is scientific methods, other one is simply the slides I think. Scientific methods, try to explain what is scientific methods, that to body. Then what is the relationship of statistics and scientific methods, and then formula. So next. Scientific process and statistics, as I told you. Next. What we are here? We have learned, we got to learn something. The people say this, inquisitiveness or necessity is the mother of invention. We say inquisitiveness are the backbone or force behind all inventions, coupled with the necessity, coupled with the requirement. We are always hankering on what is this, what for this, and why this is, and what is next. These are the things we are always thinking, always searching. And to answer those things, we are taking different ways, different methods. There are different methods. Among these, the scientific method is one of them. I'm talking about other things, other methods are also there, which are not part of our discussions, but we are discussing only the scientific method. Then, okay, what do we mean by scientific method? What are the characteristics of scientific method? Characteristics of scientific method. Scientific methods are subjected to objectivity, generality, reliability, and credibility. Subject objectivity, it should be unbiased, unprejudiced, impartial. If you are biased, if you are prejudicious, then you are not going to have objective to follow the scientific method. To follow the scientific method, it should be beyond of any biasness, any prejudices, or any impartiality. It should be free from all. Then generality. See, each and every statistics we start with the things that we start with a simple example and try to generalize the result of that particular experimentation or particular method, whatever it is. Unless or otherwise you generalize the result, you are not in a position to generalize the result. That is of no use because the findings of that particular experimentation, particular method will stick to that particular example only. So, generalizations of the result, generalizations of the finding is the most important thing in any scientific method. And verifiability. We have conducted an experiment. If this experiment will only be possible, then if it is not verifiable, if it cannot be verified, then it's of no use. It has to pass the verifiability condition. Then credibility. Sometimes what happens, we are going for particular experiment. If you repeat the particular experiment under different conditions, different situations, if that result is not okay, then there will be a doubt. What is this? Whether that experiment was correct or not. Whether the experiment, is there any something lacking? Is there any something problem that shows credibility must be there. And credibility, you might have learned about the forecasting method, modeling method, where the future projections is most important. When you are projecting the future based upon the present and past, that must be with good shades of efficiency and accuracy. Efficiency and accuracy are the two most important parameters for predictability and credibility of any scientific method. Now, in any scientific method, there are two parts. One is research methodology part, and within that research methodology, research method. Research methodology takes care of the whole research process. It takes care of its objective, its technique, its process, statistical proof, its analysis, and ultimately the findings what we are going to give for the betterment of the humanity. The research methodology, as I said, is a totality of the research conducted. And research methodology, it is the analytical part, it is the analysis part, it is the data part, it is the statistical tools what we are going to use, and the statistical part, what based on the statistical part, what we are going to infer about the populations. That is the research method part. So, by and large, we can divide the whole process of research under research methodology, and within the research methodology, there are research methods. Now, these are some notices or different types of research, forms of research, descriptive research, analytical research. These are not exhaustive or these are not exclusive. They are sometimes overlapping, mismatched, not exhaustive, as students say. One can name more other types of research also. So next, what is research design? Research design is nothing but blueprint of the research part we are going to conduct. What for the study? Why the study? What is the study? Where from the data will come? Where it should be carried out? Whether it is field experiment or it is laboratory experiment? What are the questions? What are the problems to be answered? These are the things coming under research design. Objective of research is to search hidden truth. What I am saying, all our endeavor is to know about the population, is to know about this universe and beyond this universe also, which is so long remain hidden. Okay? And in the process, what we do, we try to study the population. What is population? Everybody knows it. It's an aggregation of well-defined entities under a certain area, under a certain places or certain area. Now, this population is consisting of huge number of elements. Sometimes it is finite number of elements. Sometimes it is infinite number of elements. Okay. Now, to study this population, you need to study each and every element of the population, and each and every element of the population is constituted of innumerable number of characteristics. If I want to study the audience of this program, then we have varieties of audience persons are there, individuals are there. We need to study each and every individual unit, individual participant of this seminar or this program. Then each and every participant is composed of certain physical, certain biochemical, certain mental, and certain other types of characteristics. So you need to study each and every characteristic, and then only you can come to the conclusion about the whole population. So what I am trying to say, this population may be finite, may be infinite. If it is finite, then it is somewhat manageable. If it is infinite, then it is also a problem to tackle this problem. Now, so our objective is to study the population, because of and study of population is consisting of study of individual elements of the population. Now, if it is finite, large finite, if it is infinite, then what happens? It will take much of time. It will take much of money power, manpower, and sometimes it is not feasible also. What happens? If I say, what is the quantum of timber available in this North Bengal area, the forest area? What is the quantum of population of the rhinoceros available in the other forest? If I want to say, have a study in the tiger population in Sundarban forest, how will it do? Their questions come, how much time you are given, how much resource, that is manpower, money power, everything they will work. And even then, is it feasible or possible with the help of conventional study? What you can say, you start counting and measuring the trees from one end of the forest, and when you reach to the other end of the forest, so much time of left, time has passed, and by that time, some of the trees might have come up, some of the trees might have lost also. So you are not going to have a greater picture or an accurate picture. So we need to have some other technique. So conventional technique, nowadays there are so many techniques, but I am talking about the conventional technique. We go for this. We go for sampling. What is sampling? Sample is the representative part of the population. Is a representative part of the population. That means it is smaller part of the population. If it fails to represent the population, then it's not no longer a sample. See, through this chart, I have tried to make you understand what we mean by sampling. Okay. These are the populations we have studied. This is not a rectangular one or this is not a circular one. It might be different way. This is also of about the finite population. Populations may be infinite also. So we take representative part of the population, sample 1, sample 2, sample 3, and so on. And sample is very easily manageable. So we study the sample behavior. Instead of thousands of elements in a population to study, we are taking 10, 15, 100. So we are studying the sample behavior and using the statistical tools, statistical technique, we are trying to infer about the sample as well as we are trying to know how are the sample characteristics, sample behavior are acceptable about the population or otherwise. So, our objective was to study the population. Our objective was to infer about the population characteristics and because of certain constant, as I have told you, the time, resource, etc. We are taking sample, we are collecting sample observation, sample data, analyzing the sample data, and based on the sample data, we are inferring about the population. This is the conventional way. Nowadays, they are having so much of development of statistics, data analysis, and other things, and this process has been modernized, modified. The sampling theory, what type of samples should I know? See, in this audience, there are variability huge. What is variability? There are boys, there are girls, there are professors, there are scientists, there are research scholars. So these are the variability as I can understand. So your sample should have incorporated all the variabilities within it. Otherwise, it's no longer a representative part of the population. So to be representative part of the population, the sample must be accomplished with the variability of the population. Well, most of the time, this is most practical thing is that most of the time we are wondering about what would be the sample size. What makes sufficient to have a sample. So sample size again depends on whether it is in finite populations or finite populations. There are sampling theories, there are sampling procedure based on which the sample size is being determined. So sample size, before determining the sample size, these are the point, these are the particular things we should remember and we should know if important, and then we go for selection of or fixing of proper sample size. Now I have given here two methods, though not applicable everywhere for infinite populations and for infinite populations. How to decide these things? So this is the formula. This is given to the help of chi-square and other things. Sample size is being selected for infinite population and for population, finite population. These are the two methods I am trying to make to understand. Second, next. See, this is the thing. With the example, I am trying to show you how, with the change in population size, the sample size, selection of sample size, with 10 population size, mostly in case of medical science, in case of other exercise or research dealing with animal uh, objective, where there will be you won't get that much of samples, that much of element. So there you need to have a sample. You need to have this. So if you are having a population size of 10, there is no question of sample. Population size itself will be the sample size. Now you come down, go to the first slide. For 10, this 10. For 100 pp population size, it is 108. For 460 populations, it is 210. For 2200 populations, that is 327. That means, what I am trying to say is that as we go on increasing the population size, and it reaches or approaching the infinite population size, the proportions of population elements to be selected in the sample decreases. So at the very beginning, with a small population size, you need to almost mimic the population to have a sample. This is an abstract idea and an example that I am trying to visualize you. Next. What are the sampling techniques? Depending upon the variability of the populations, we need to have two different types of sampling technique. One is probability sampling, another one is non-probability sampling. We are almost everyone is accustomed with simple random sampling. Simple random sampling with replacement and simple random sampling without replacement. Simple random sampling is nothing but population and is being drawn from unit is being drawn from the population with equal probability. That means out of this audience, I can pick up anybody with equal probability. There is no question of differential probability that this element will be selected, this unit will be selected rather than this unit. So every unit has equal probability to be included in the sample. And SRSWR means simple random sampling with replacement, means that we can replace the selected element before drawing the second unit from that particular population. But SRSWR means you cannot return back the selected units to the population before drawing the second one. This continues. I think everybody knows this. But this is a value probability sample. If I want to draw a sample from this audience, then we need to study how many girl students are there, girl participants are there, how many boys participants are there. Then, according to probability, proportional to size, we have to selective for selection of the particular sample. This is one thing. Second one is stratified sampling. You divide the whole population into different strata. Then systematic sampling, then cluster sampling, multiple. So, what I am trying to make you understand is that depending upon the nature, variability of the population, we need to adopt one of these sampling technique. One is probability sampling, another one is non-probability sampling. We are almost everyone is accustomed with simple random sampling. Simple random sampling with replacement and simple random sampling without replacement. Simple random sampling is nothing but population and unit is being drawn from the population with equal probability. That means out of this audience, I can pick up anybody with equal probability. there is no question of differential probability that this element will be selected, this unit will be selected rather than this unit. So every unit has equal probability to be included in the sample. And SRSWR means simple random sampling with replacement, means that we can replace the selected element before drawing the second unit from that particular population. But SRSWR means you cannot return back the selected units to the population before drawing the second one. This continues. I think everybody knows this. But the thing is a very probability sample. If I want to draw a sample from this audience, then we need to study how many girl students are there, girl participants are there, how many boys participants are there. Then, according to probability, proportional to size, we have to selective or selections of the particular sample. This is one thing. Second one is stratified sampling. You divide the whole population into different strata. Then systematic sampling, then cluster sampling, multiple. So, what I am trying to make you understand is that depending upon the nature, heredity of the population, we need to adopt one of these sampling techniques. And mind it, that each and every sampling techniques are not acceptable, are not applicable under each and every situation. So, depending on the variety, various of the population, you need to select. Depending on the objective of the selections of the sample, you need to take into account the exact method of the sampling technique. And non-probability sampling. This non-probability sampling, the quota sampling, judgment sampling, purpose sampling, snowball sampling, accidental sampling, these are nowadays gaining importance. Another method is the bootstrap sampling. These are coming into its very what for? In medical science and clinical trials with animals, you will be having a small number of elements. So population size is very difficult to define. Or sometimes you have a small population. In that case, within the ambit of sampling theory, within the objective, within the statistical theory, these have been non-probability sampling have been designed. Quota sampling, judgment sampling, purpose sampling, snowball sampling, accidental sampling, but that like these things. That again depends upon the population, type of objective of the study, and depending upon the objective of the study, we will go this particular type of sampling method. I am not telling that non-probability sampling is not out of protection, out of code, but always the probability sampling is better than non-probability sampling. But under certain exigencies, certain situations, you need to opt for non-probability sampling also. So we need to know about the non-probability sampling, their pros and cons, and where to use, how to use these things. We should do. And research, particularly research, is very important. Yes. Now, once you have drawn the sample, you need to collect information, collect data, or information. Now, sometimes we mix up what is information, what is data. Those are not exclusive, but they are in silver line. I am talking about numerical data, collection of data. Collection of data can be made from the existing population. Collections of data can be made from the conduction of experiments. Experiments you can conduct for a particular purpose and you can collect data. Most of the time we do it. The difference between these two is that you don't have any control over the existing populations. But when you are collecting data under experimental conditions, the experiments are generally controlled, experiments are generally conducted under certain rules, certain conditions, and these conditions are or can be modified, can be changed, can be enacted by the experimenter himself or herself. So, experimental data are prone to less fluctuation than your existing population data. Population in social science, in behavioral science, there you won't get existing or experimental data sometimes. But we have to have the data from the existing population. So there you don't have anything to do. You can go for collection of data. Now, what do you do? What type of data we collect? We're going to collect. We collect information or data from the characteristics. As I showed you a second, that individual, each and every individual is consisting of innumerable number of characteristics. And then you have to define the group. You need to study. So, and there are certain common characteristics which do not change. This is known to all. The characteristics can be divided into two parts. One is variable part, another one is constant. Constant, restricted constant, unrestricted constant. I'll give you some small example. Everybody knows the acceleration due to gravity is a constant. Everybody knows the universal gravitational constant is a constant. So the difference between this small g and capital G, small g is changeable. It can change, it can fluctuate a little bit wide range. But capital G remains in. So that is the idea. We have restricted and unrestricted constant. Now coming down to the variable. Variable sometimes it is measurable, sometimes it is non-measurable. That is why I am talking about quantitative variable and qualitative variables. Gender, complexions, color, all these are qualitative variables. And others which can be measured are quantitative variables. So, while using statistical tools, you must be very, very careful that same statistical tools cannot be used in both quantitative characters and the qualitative characters. You need to be very, very choosy the type of characteristics and the statistical tools to be used. So, the characteristics measure variables. Depending upon the natures of the variables, there are different types of we explained, we in the nomenclature, so we put a name to the variable, and that may vary from purpose to purpose, objective of the study, situation. These are some of the examples of different types of variables noted here. That this doesn't mean these are exhaustive. You can have different ways of different outcomes. Now, when we are talking about variables or quantitative variables, it needs to be measured. What is the measurement? Measurement is the process of assigning number to the observation. Depending upon the measurement scale, different types of measurement, there are different scales: nominal scale, ordinal scale, interval scale, and ratio scale. Nominal scale, ordinal scale, interval scale, and ratio. You see, just putting a number to any element is called nominal scale. See, the players in the Indian cricket team, they are being put in different numbers, 1 to 11, sometimes 999, sometimes 9990. Does it mean the player is 99th player? Does it mean the player is first one? Something like that. Just we are trying to put some figures to the player so that you can identify. So this is also variable. Variables also measured or variables. In ordinal scale, what is there? There is a gap. You want the gap between 1 and 2, 2 and 3, or something like that. Ordinal scale. And interval scale, there will be interval. The same interval. The example is given, that temperature interval is given, their temperature example is there. And second thing is that last is the ratio scale of measurement. There will be ratio by the 0. That means there will be lowest level 0 and you are increasing at a constant level. So these are the mainly four different ways of measurement, different scales of measurement, what we encounter in statistical going to analyze any variables under statistical tools. And I must say that the analysis also varies depending upon the different types of scales and different types of measurements. collection of data can be from primary data or secondary data. What is primary data? All of us know it. When the experimenter collects his or her own data for his or her objective, for his or her own purpose, then it is the primary data. Experimental data, primary data. Population data from population is also primary data. It's also primary data. That means data collector himself, data generator himself is using the data. But secondary data, so when the data is going to correlate the progress or longevity of a particular unit, particular result, particular variety in a correlate with the weather pattern. So weather data, where do we get? From other sources, the mathematical department or the mathematical station. So their duty is to collect the weather data, the mathematical data, the rainfall data, humidity data, temperature data, and so on. So on. And we are taking help from them to analyze our data. So to us, it is secondary data, but to them, the primary data. Now, depending upon the method of collection of data, particularly the secondary data, we must be very careful. Where from we are getting the data? What is the source of the data? What is the method of collection of data? Method, whether particular method, what has been given there is properly followed or not, what is the accuracy of the data, under which situations the data can be utilized, or what are the pros and cons of the collection of data. Unless and otherwise, you know it, there will be problem in analysis of your data and your findings may be faulty one. Say for example, in a very crude sense, quite frequently we use FAO data, Food and Agriculture Organization of United States in United Nations data, but in scientific community, these data are given lesser importance because FAO collects this data from the component countries, and in countries come down to the states, you know how the data are being collected, how the data are being changed. From your practical, from your block level, village level, district level, then state level, you go every year how it changes. So, authenticity of the secondary data is of utmost importance. Is of utmost importance. If you have a little bit of doubt about the authenticity of data, about the process of generations of the data, that may lead to very awkward situations in analyzing, in drawing inference of your data. These are the already discussed these things. Yeah. Processing and analysis of data. Processing and analysis of data, whatever we collect, may it be primary data, may it be secondary data, is raw data. That needs to be scrutinized. Don't jump into the analysis or drawing conference based on the data, whatever you come. Whether the data is matching with your objective of research, whether data source is correct, authentic, whether the data are correct, that has to be ascertained. In that process, scrutiny of data is most important. Mostly, the secondary data needs to be scrutinized carefully, mostly. Because, on the other hand, the primary data or the experimental data or data collected by the user himself, he or she is in control of the data generation process. So that is little bit. Now, next comes the arrangement of data. Problematic data we have discussed later on. Data technique. Then we come to the coding of data, the classifications of data, then presentation of data. So once you get the data, try to see how to have a picture what is there in your data in first information. So my honest request to each and everyone is that you try to visualize the data. Once you have got the data set, you just draw a scatter diagram. You just visualize this. Everybody is conversant about the use of computers. So you see the nature of the data by drawing the scatter diagram or any diagram, whichever is feasible. You try to perceive the nature of the data. And from that, you can have a preliminary idea in which way this analysis should do. Further analysis should go. Next. If you need to classify the data, if you need to group the data, then these are the these are the two popular and given reference point. Next, coming down to the analysis. Analysis of data in statistics. This is not inclusive. This is not exclusive. This is an example only. What are the different types of analysis you can have? So, data analysis mainly of two types. One is descriptive analysis, another one is inferential analysis. What I said, we need to study the population. Because of certain constraints, we are taking help of the sample. We are studying the sample, and drawing inference based on the sample characteristic, sample observation. Right. Now, once you have drawn the sample, you have studied the data, you have taken the data, you describe the data. One of the major important points of describing the data is your scatter diagram or plotting of the data, whichever it is. Second thing is description. In description of the data, there are different techniques. There are univariate method, bivariate method, and multivariate method. In univariate method, you need to know what is the measures, what are the tendencies, central tendency, what are the dispersions, what are the associations, and so on. What is central tendency? If I want to represent this whole audience into a single figure, we opt for arithmetic mean. Generally, or median, or mode, that is by to the help of this arithmetic mean, or median, or mode, whatever may be, we try to represent this whole audience. So at the same time, the central tendency is there, the dispersion is there, that means variability also there. How much variability is there within this audience? What for? And then that we want to know what is the middle value and what is the tendency, what is the dispersion value, how the data are dispersed. So dispersion and central tendency are the two faces of the same coin. One is central tendency, the central value, and the one is how much data are dispersed. This gives you, these two measures gives you an idea that what type of analysis should you follow in further stage and about your data. Bivariate analysis, sample population, when sample regression, bivariate between two variables, then associations of attributes, to a ANOVA, etc. Then multivariate analysis, we have multiple correlation, partial correlation, multiple regression, or path analysis, and other things that will be there. Now, these are the descriptions of the data what you have got from either through primary sources or secondary sources. Then you know the nature of your data. Know the nature of the data. You have done. Now, what is our objective? Going back from sample to population. Because our objective is to draw inference about the population. So, how to go back from the sample to the population? That is through inferential statistics. In inferential statistics, there are two skills. Generally, and telling once again, these are not exclusive. This is just guideline. One is estimation, and one is testing of hypothesis. In estimations, what is the population mean? I want to know. So I have drawn sample mean. Whether that sample mean is applicable for the whole population or not. I have got sample variance. Whether that sample variance is applicable for the population mean, population variance or not. that has to be known, that has to be asserted through inferential statistics. Then only we can say the sample characteristics are applicable for the whole population. Right? So, with the help of this estimation and testing of hypothesis and point estimation and estimation, we can do this. Now, coming back to the testing of hypothesis, I have noted here the parametric hypothesis and non-parametric hypothesis. They are semi-parametric also. Okay? And there are other methods. Nowadays, the machine learning process is coming, machine learning method coming in a great way. Great way. Sometimes we the statisticians fails to what is that get the explanation behind how these results are coming, and ultimately we reach the conclusion, but that gives us their idea. Yes. Okay, so our objective, our work is to study the sample behavior and draw inference about the population. So if samples are drawn properly, if the samples are studied properly, if you have used correct statistical tools, then only we can reach to the correct decision, correct inference about the population characteristics. So in each stage, there is a possibility in committing error, committing mistake. See, what I have given here, this is a statistical inference, null hypothesis. What is null hypothesis? Null hypothesis is that any of unbiased, unmotivated assumptions about the population range. Any of unbiased, unmotivated assumption about the population characteristic is termed as null hypothesis. Second, mean of the student, mean of the audience of this is mean degree is master degree. This is the observation. This is the statement. Now, with the help of data collection, with the help of statistical inference, I want to know whether that statement was correct or not. If I have failed to draw a proper sample, if I have failed to use the proper statistical tools, if then our result or the conclusions about the population will be different. So we come across four different situations. Whether statement is true, but null hypothesis is rejected. That means that we in education is not master degree or something. This is correct in population, but based on the sample observation, sample study, we are rejecting it. So we are committing error. That is called type 1 error. Again, the first null hypothesis is true, but we accept these things. So this is the correct decision. Correct decision. Second thing is that null hypothesis is false, but we are rejecting it. Okay, so this is also correct decision. But null hypothesis is false, but we are taking it or accepting it. That means we are committing an error. So out of four, there are two types of error. One is type 1 error, type 2 error. In statistics, what I should say is an abstract one. It's talk about the population, it's talk about the sample based on sample observation. Now, these two types of error have inverse proportionality. If one goes, out of these two, which one is more dangerous? So, what we have said, the statistical law, that you face with type 1 error, and this one is minimized. This type 1 error is called, probability of type 1 error is called level of significance. What we call generally the P value in general sense. So level of significance, 5% level of significance, 1% level of significance, 0.1% level of significance. So we fix that one. That the dangerous error is being fixed. How is this and coming back? Then other one is minimized. This is the technique we use, and to use this technique, we need to adopt a particular type of statistical tools in inference. How should I fix the level of significance? in biological experiments, say for example, or agricultural experiments, when you are comparing the varietal performance, which variety among the 10 varieties is superior, then you have the liberty to increase your level of significance by 5%, 10%. In social science also, you have the liberty to increase that. But in medical science, in clinical science, you are testing the efficacy of a particular drug. You cannot have the luxury to take such a risk that 5% would be the type of error, 5% would be the level of significance, or 1%. You would stick to the 0.01% level of significance because that will be severe. 1% is out of 100, you are taking risk of 1. That cannot be. So depending on the nature of the research, depending on the objective of the research, you need to fix the level of significance. One way of this time to error is called the power of the case. How efficiently you are doing the test. So this is in nutshell what I try to say when the statistics in research. Now next we are coming to the role of statistics, statistical software, use and misuse of statistical software. So these are the glimpses of statistical tools what conventional statisticians are using. These are not exhaustive. These are just to know. The role of statistics and statistics. See, many of the statistical tools would have not been used or would have not come into force if the data analytical tool, data analysis was remained so complicated. Particularly, the multivariate analysis or beyond multivariate analysis, it would have been a difficult proposition without getting support from the computer software computer computer. With the passage of time, with the advent of computer technology, what's the time? Almost. Another? Another? Okay. So, with the advent of computational technology, we are in a position to use many more statistical tools, particularly the multivariate techniques, multivariate analysis, multivariate. And statistics sit everywhere. In our daily life, we use these things, either knowingly or unknowingly. Every sphere of life. That is the use of statistics in these things. Next. These are all what we have discussed, what I assessed just now, that without the advancement of computing facility, you are not in position to use the statistical tools or to unearth the hidden information within a given data set. Next. So, like a coin having two faces, so use of statistical tools with the development of statistics and computing facility is not only unidirectional, it has got pros also. Use and misuse. So statistical theories and the set of data are best used on informative at the hands of a good statistician with an appropriate computing facility. So statistician is there, computing facility is there, but the subject is different. If you don't have the idea of a particular subject, minimum level of idea, biology is what it does. It's a combination of biology, computational facility, etc. So, one bioinformatician, he or she must be well acquainted with the three phases of the three disciplines. Biology, he must have biology, he must have computer physics, and such. Also, on them only, he will be in a champion position to explain the bioinformatics subject, or explain the bioinformatics subject. This is written there. Next. This is the quotation what we are written. See, statistical or the computing facilities are open chosen by more availability of the user friendly statistical software. I have got the package, what is available there, that remains, that restricts my use of statistics in my institute. We have not that luxury to use the exact statistical tools what I can use, what I perceive to be used because of positive, because of that. So this is there. We need to compromise. We are compromising every time. So that with that, we have to go with this. Role of statistical software, not that we have discussed. What is GIGO? You need to know the statistical software what you are using, what the data, the type of data you are feeding, the formations of the data, pattern of the data, you need to feed, pattern of the analysis available, the algorithm developed, algorithm used to develop the particular package, particular program, particular analysis that you should know. Otherwise, what will happen? GIGO means garbage in and garbage out. Garbage in and garbage out. So garbage in is taken into consideration with the help of scrutiny of data, with the help of other things, etc. But garbage out, you don't know how the what type of analysis the package is doing, what type of analysis the software is doing, and what are the algorithms they are doing. I'm giving you an example. You everybody has used most probably the MS Excel. Most probably I think so. In MS Excel, data analysis technique, you see there will be so many types of variance analysis. So many types of variance. Variance A, variance B, variance P, and so many. What for this? You should know these things, what the computer software that is MS Excel is trying to say by variance A, variance B, and so many. These are the otherwise what the data is giving, what the output is providing to you to know. Whether it is matching to your objective or no, that also you do. So that's why that is in gravity. So what I have tried to say here, the knowledge about statistics, the knowledge about the specifications of the software. Mr. Dikla, along with the software. Next. These are the things of part we have discussed. Keep this thing. Let's see. We have not that luxury to use the exact statistical tools what I can use, what I perceive to be used because of positive, because of that. So this is there. We need to compromise. We are compromising every time. So that with that, we have to go with this. Role of statistical software, not that we have discussed. What is GIGO? You need to know the statistical software what you are using, what the data, the type of data you are feeding, the formations of the data, pattern of the data, you need to feed, pattern of the analysis available, the algorithm developed, algorithm used to develop the particular package, particular program, particular analysis that you should know. Otherwise, what will happen? GIGO means garbage in and garbage out. Garbage in and garbage out. So garbage in is taken into consideration with the help of scrutiny of data, with the help of other things, etc. But garbage out, you don't know how the what type of analysis the package is doing, what type of analysis the software is doing, and what are the algorithms they are doing. I'm giving you an example. You everybody has used most probably the MS Excel. Most probably I think so. In MS Excel, data analysis technique, you see there will be so many types of variance analysis. So many types of variance. Variance A, variance B, variance P, and so many. What for this? You should know these things, what the computer software that is MS Excel is trying to say by variance A, variance B, and so many. These are the otherwise what the data is giving, what the output is providing to you to know. Whether it is matching to your objective or no, that also you do. So that's why that is in probability. So what I have tried to say here, the knowledge about statistics, the knowledge about the specifications of the software is required along with the software. Software. Next. These are the things of part we have discussed. Keep this thing. Let's see. So, before using any statistical software, we should have this ready. What we want, what is our objective, whether the data available to get to the computer for that specific program or not, my data whether it is compatible or not. Second thing, is it feasible to get the information from the data fed to the computer following the statistical theory. One thing is that I have a set of data, I know what type of tools to be used, I have computer programming, computer software. So whether all these three are matching together, then only I can reach to the ultimate inference about the population. Otherwise, any of all these states will lead to the misleading information. Okay? Next thing is the what should be the direction to the computer. What should the command to the computer? Okay? Next, what are output here? You can give this a 5 data point, you can have a 5 pages of output or more than 5 pages of output. What to do with this one? What to do? Whether I am in a position to explain the output generated by this, if I am explain, then I should know what is the algorithm, how they have been done, what is the use to satisfy my objective. These are the main points. Every graph must be ABC. Then how to interpret the output. How to interpret the output. Next. Sorry. In each and every software, there is specification for each and every program for data arrangement. If the data arrangement is faulty, you will get output. That may not be matching or commensurate with your objective or with the data. Okay? Wrong, improper mathematical and statistical formula embedded in the software. This has been discussed. We have already discussed the how the statistical tools, what I am going to use that has been done in that particular computation in the same fashion or not. That has to be assigned. What? How to do it? You take a small example or work out the example and work out that example with the help of the computer software. If these two matches, then only you will work out this. But in many cases, for multiplicative analysis, for what higher analysis, you may not be and you may not have that last value. Okay. So by part, you have to have this. This R programming, we are doing this. Last 1 week, I was trying to do something. The lab programming. When R programming has a huge library, you can generate, you can incorporate programs from different sources. Now this, depending upon the command, depending upon the program, how we are going to say, they will give you different types of results. I was trying to analyze the Markov chain analysis. It has given me the row wise only one cell that is 1 and other cells is 0. 3, 4 times. So I was wondering what happened. I could find that there was a mismatch, the noting down or jotting down programs from different sources, part by part. So we have to be very, very careful. These are all about these things. What are the precautions to be taken? The background knowledge about the statistical package used with respect to three things: algorithm, technique used, performing the task. Secondly, testing of accuracy, that's what we have solved problem, that what we have already discussed, and knowledge about explanation of the output after running the statistical package used. Sometimes we very much But we jump into the presentation of output for whom we don't have any idea. For any idea. So be different from using or from picturizing those elements where you don't have that much of knowledge. And you are not sure what are these things, why these things, what are these things. Now, as I told you, that with the help of example, we try to glimpses of mistake or use coming to. But I am sorry that it may be agriculture bias, but the same thing, what you will be doing these things in your subject, in every subject, you get idea. See, regression analysis and correlation analysis. All of us do it. All of us know about it. Simple correlation. At best partial correlations. But there are host of correlation coefficients. There are host of correlation coefficients. Partial correlation, simple correlation, partial correlation, rank correlation, part correlation, binomial correlation, point binomial correlation, correlation of components, correlation of attributes, and so many. Where do they use? Are they used in every situation? And what are the assumptions in simple correlation analysis? The simple correlation analysis is based on two main assumptions. One is continuity, another one is normality assumption. So the continuous data and normality assumption. Normality. But in social science, in professional science, when you are counting the data, the inside per population, that will be count data, small number of data, do the following normality assumption. If I arrange this whole this audience into their complexes and rank them, do this rank and the height of the audience of the story and correlation between these two can be worked out with a simple correlation coefficient, because the rank what I am giving is not following the perfectly adapted is not continuous. So under the given situations, what type of correlations to be used and what is the implication, that has to be known before utilizing the statistical software for calculations of correlation. Most of the statistical software they are giving the different types of correlations. I have been taken the importance of two things. Where if I have taken, as I told you, I am biased a little bit, agriculture bias. If I have taken and thin per meter square. This is an example from paddy field, thin per meter square, and effective tiller per field. Paddy, effective tiller. And the correlation coefficient between 1 and 3, see, below it is given there. The simple correlation coefficient, the part correlation coefficient, and the partial correlation coefficient. You can see the simple correlation coefficient is significant, but the part correlation coefficient is not. But computer will give you everything. If you want to take that comment, computer will give you. But you have to have an idea what type of correlation I should do. This is an example. Don't jump to the conclusion. Don't jump to the use of whatever the computer is providing to you. Okay? Next one. Binomial correlation, as I told you, it's a continuous dichotomous variable, but taking that, the continuous, if it is continuous also, then also it's taking normality assumption. Continuous variable is a dichotomous thing, either 0 or 1. 0 or 1. Say, salary, age of a college student and a college student. So one is gender, yes or no, 0 or 1 or 1 or 2, whatever may be. Other one is age. What type of correlation do you use? If it is normal, the 0 1. If you can find that this is normal, then you can go for bicycle correlation. If it is not normal, then you go for point bicycle correlation. So you should know what is the difference between bicycle correlation and point bicycle correlation. Then only you can command the computer that I need bicycle information or point bicycle information. Right? Otherwise, next. This is the same example. I have given bicycle correlation, simple correlations, what I told you. Then see the difference. Red one. The value, you can see there's a drastic change in value. So depending upon the nature, depending upon the analysis, you will get different types of results. Now, which results will be fitting to your objective, that we have to decide. Otherwise, it's very difficult to reach into a misleading. Regression analysis, I was telling you, in MS Excel, you don't have any idea to go for regression analysis. And each and every program, every software, there are some commands where you have to put input. You have to put the command. See, this is the example. This is just like in class regression model. Then next, come down. Next. See, these are the middle. Now, the red one portion. Nothing is written there about the residual. I don't give you what residuals, nature of the residuals here. So, what is the output? See, this is the output. Multiple R square, adjusted R square, other things and this kind of. So, if you don't know what is multiple R, what is R square, and what is R square, adjusted R square, the relationship among these, you will be wondering how to utilize these things. So you have to be very careful. Very careful. Next. These are the results we are given. There was no questions of residual. So we didn't get residual here. The regression coefficient. The only the variable A is significant here. Other variables are not significant here. See, this is P value. P value is talking about level of significance, 5% level of significance. Next. The same analysis and the consideration, but with the residual. Next. See, coefficient error, same thing will come. Next. See, it has given the residual as well as the predicted value. For each and every set of values, we are getting the predicted value, we are getting the residual value. So, depending upon the command, fed to the computer, you will be getting the desired output. Now, you have to have exact knowledge what is the output value. So, you get accordingly. Next. This data again has been fed to the SPSS exam. SPSS is more wide person, has more opportunity, more flexibility. So I have used that one to show you how the data changes, how the result by and large do not change, but how there are certain things. Next. These are the commands you have to give before analyzing. Go. Now, in SPSS, you will get so many processes, so many techniques of analyzing the regression process. See, what is there? There are engines, there are forward, backward, statewide, so many. You have to know, you should know what are the differences. What do you mean by forward regression? What do you mean by backward regression? What is stepwise regression? What is engine method of regression? Otherwise, you will be in a great trouble. You may not get any result. Here you see the mark one. There is a provision F to enter and F to reject. What does it mean? When you enter a particular variable, inclusions of a particular variable in a regression model is dependent upon the level of significance. And exclusion of the particular variable from the model is depending upon the level of significance. Let me take one simple example. These are the correlation matrix you are getting from the SPSS analysis if you have provided the correlation. You are not getting there in the Excel sheet. So this is the difference. Next. See, Variable enter. First one is x9, x1, x5, x6, x3, x7, x8, x2, and x2. What does it mean? Why not x1 first? Why not x1 to next? Why not x3 first? Why? How this order has come? So this is a multiple situation, and the algorithm has been made in such a way that it takes care of the most possible variable with the y first, then second, then third, then fourth. This one. This is the entire process. So this is somewhat different from that of the output of the MS Excel. And you will find this everywhere. So next. Next. See. Yes, we do. So the results. Additionally, what you get here is partial correlation and part correlation. So many outputs you can have from depending upon the data value, depending upon the statistical software. But you must be in a position to explain these things. What is the difference between part and partial correlation? That you should know. Whether it is pertinent to have a part correlations or a partial correlations to my context. That has to be known. And what is the implication? What is the explanation of part correlation? These are these things. See, these are negative ones. These are negative. There are certain things which are not negative but positive also. It is there. See, last but one. Point 176, point 343, 329. This one. Last one. See, these are the things you have to know. You have to have idea about what are the output we are getting. So this is again. Now, this is a common mistake. What we do in gel, right? Without going into the validity of the regression analysis, we draw inference about the validity of the draw inference about the from the regression analysis. See, same variable, but different data computation, different number of observations. One is having regression. I'm talking about analysis of variance, regression, residual, and total. What is the regression degrees of freedom? 1. What is the residual degrees of freedom? 8. To the next place, the regression is 1, residual is 13, the total is 14. Now, answer is 0.90, answer is 0.817, their answer is 0.787. There is not that much of difference between answer between these two analyses. But it seems that both the analyses are correct. Correct, no? But the thing is that you cannot use the first one because it is not statistically viable, statistically acceptable. Because we need to have at least the residual degrees of freedom 12 or more. Residual degrees of freedom 12 or more. What for? Because we are going for F test, significance of F test. F test is very much valuable beyond or before 12 degrees of freedom. Very much valuable. It doesn't follow the normality assumptions. So if we don't know that one, so these data will be there and we will be drawing inference based on this one. So these are the other minor things, but we generally overlook. That should be taken into consideration because we are doing research, we are drawing inference about the population for the betterment of the humanity. Next. Violation of assumptions of ANOVA. Opening combat was with different types of data, count data, percentage data, all these things are coming up. This count data and percentage data, they do not follow the assumptions of analysis of variance of normality or variance assumption with zero frequency. So we need to transform this data before analysis of variance, taking aware analysis of variance. Now different types of data, these are different types of transformation. Different types of, there are logarithmic transformation, there are square root transformation, there are angular transformation. Okay? Now with the help of the example, I have shown where to data transformation. So this is one example. Okay? Next. The relationship between mean and variance. This is mean and the range they are taken. So if there is a range, then this data doesn't follow the normality. Highlighting normal, highlighting independently, identically independently distributed normal variant with zero mean and sequential variant, that is not followed, then we have continuation thing, and that is violated. So the very output of the analysis of variance will be under question. So we need to transform the data before analysis. This is an example. Taking the same example, how these two add, how the results add. Okay, these are transformed. These are the next. See, okay, how the analysis of variance changes. Then critical error value here. I'm talking about this one. This is not significant, but here you see this is significant. Okay, with your original data, that was non significant. That means there was no differential among the treatment. But with the transform data, you are getting that this is significant. That and actually that's significant. So with the following of the exact procedure, you have changed information. You have changed drawing about the population. Next. This is again one example. So how to analyze this data? Nothing is there. We have said there are nitrogen, different doses of nitrogen, conducted over different seasons and different diagonal. So these are the different types of analysis. Which I have given you here the example of 6 types of data. But you see, look into the analysis of various source of variations table. There are different. How to analyze this data? Nothing is there. We have said there are nitrogen, different doses of nitrogen, conducted over different seasons and different diagonal. So these are the different types of analysis. Which I have given you here the example of 6 types of data. But you see, look into the analysis of various source of variations table. There are differences. There are differences. Next, see, where is the season? Such a very circle one. Under analyzing the various structures, it changes. Next, see, where it has gone. Got it? It's changing. Next, see, the error, number of errors is changing. So the analysis of various structure is changing. Without having proper knowledge about the experiments what you have conducted, you can have the possibility of analyzing your data in this different way. And how these differ in analyzing the output. That I am trying to show you. Next. Same thing. Yeah. Also, so these are the types where you can use or how you can use the analysis of variance. This is in nutshell the sheet. Taking one example, what is there? There are 3 factors: F1, F2, and F3. One factor is having second is 2, 2, and 5. So 2 into 2 into 5 factorial analysis. Without having any knowledge, how we can analyze the data? Next. So, see how many? 8. Go again. See, no. See, 14 different types of analysis could be done. 14 different types of analysis could be done from a given type of data. Now the question is, which one is correct? Which one we should adopt? That is the main question, and that is beginning to the objective of your study. So you should be careful about the subject, about the what is it say, the type of analysis required to address the objective question. With one example, one problem, you can analyze these things in 14 different ways. One can have another ways also, 4 ways also. So you should be very careful. Combined analysis of variance. I should say. We have conducted one experiment today. Next day you are conducting one experiment. Next day another experiment. The same experiment is being repeated in 3 different seasons, in different days, or 3 different months, 3 different locations, or different. So before releasing a variety, you need to have a locational trial. Locational trial, different locations, how the stability of the variety particular variety varies over different locations. So how to combine these analysis into one, so that I can say this variety is particular variety is stable one or not stable one. So we need to combine. What we do generally is that we average the output over the situation and analyze that situation. That means from 5 different locations, replications wise we average it and then analyze it. But that is a wrong idea. We have to incorporate the effect of location, effect of season, effect of year, effect of days on which you are conducting the experiment, and the type of experiment, or the number of times you are conducting that experiment. So you need to, so there should be an interaction in between the location and the treatment effect. So that would be the correct one. So this is the next one. Yeah, why treatment wise I have given you. These are the differences in analysis of variance technique. So, if the analysis of variance technique is different, then also the analysis and then also the conclusion of the analysis. Again, the particular type of design is fixed when you have fixed the objective of your experimentation. Once you have fixed the objective of the experiment, you need not to be worried about the type of design that is also fixed. Missing data of data imputation. Data imputation, as I understand, is a great problem in bioinformatics analysis. Agriculture, biology, everywhere, it is there. Result of different imputation analysis also differs to the imputation technique. The category you will be knowing better than me in this case. This one is the categories of missing data. There is the structurally missing data, recently missing completely at random in data, then MMR data at random, then the MMR data. These are the data, missing data, type of missing data, you know better than me. This is the thing. But the analysis of this type of data, different types of data, cannot have it. Our objective is how to improve, how to replace the missing data. Mean impedance. Generally, what we do, get the mean of the non-missing data. It has been modified a little bit. The missing data of same category or are replaced by the non-missing data of the same category. Non-missing data of the same. Then what we do? We build up a model based on the non-missing data, and based on the model evaluation, model gives us data to be replaced. Then again, multiple models, multiple imputation method, the same thing is repeated. That different overhead same imputation method uses an external source from external. You are using meta-analysis, you are using big data analysis, and meta-analysis is playing a havoc role in this type of overhead imputation method. So you can have different types of imputation data imputation method. Let us have this is from again agriculture. Best example in agriculture field, most of the time we get missing data. But one thing to keep in mind that missing data does mean zero data. Zero is also a figure. It cannot be confused with zero value or missing value. Missing value, so that's the experiment conducted, but we didn't get any information. But zero information means it's also information. That has to be taken into consideration while analyzing. So, difference between zero data and missing data should be clearly understood. Here, I am talking about the missing data in completely randomized design and the missing data. This is the model building step. With the help of model, we have found out the missing data. Or you replace, you include that missing data and go for analysis and you follow the method. But the critical difference and the comparisons of mean will be different for different design. Next, let us go. See, comparison standard error 231. They do differ. The any treatment which has got missing value can be compared with different precision with that of the treatment which is not having any missing value. Yeah. So there will be a difference in missing value. This is one of the imputation technique in agriculture field experiments. This is the Statistical design. There are different methods we have discussed it today. Normal integration method, fast level, integration method, or model-based integration method, and we have discussed. Next, basic learning algorithm like random forest and KNN. These are mostly used in your subject matter. Most. So you will be having better knowledge. Now, with the help of the structure, the provider, and try to understand how this random forest works. How the now in this portion, this is a great question. This is a great point of interest. How do they work and how do they work? In you might have comments about Day-1 network. No? Neural network, like neurons work in our body. So there is a modeling technique called neural network. And it was a major research area. How the neural hidden layer and the input layer works together. Similarly, here also, how this random forest method works together. That is the machine learning was the basic things you have to have. PA nearest neighbor. I'll be taking the clustering technique. Clustering technique is also PA neighbor. I'll select the most closest neighbor. Then again most closest neighbor. There are two techniques in clustering. One is nearest neighbor and another farthest neighbor. And these have been used here. PA nearest neighbor and for clustering measuring the distance and integration technique. These are the challenges. All the wide spectrum of mixing value imputation method are available using the high throughput platform, and new ones are constantly being developed. This is the issue. This is a research area. It is continuously. The performance of imputation method may vary drastically from one situation to another. So we have to have a wide closed loop into the different methods and different processes. Bioindexing and indexing is another method in biological science. Biological science. And new people are using mostly the students of biology. It's not bioindexing for biology students. These are being used. I tell you one thing that in America, out of 31 presidential elections, 29 elections have been protested through bioindexing method. 29 correctly being protested through bioindexing method. What does it mean bioindexing method? It's a combination of all characters into one value, so that the prospect of a particular candidate can be given with a single value, so that we can forecast which is going to before this Trump elections, Trump and other before these 31 elections, out of 31 elections, 29 elections were perfectly forecasted with the help of biology. So biology is not only for biology students, it is also for social sciences, for economics also. I have given you here some examples of biology. You live it. So already you know. So these things people know things on index, identify index, something on index, so that you use these things. We are not interested on these things, but point of interest is how we are going to use the statistical tools for this biodiversity, for comparing this biodiversity. Go on, go on, go on, go on. Example, go on. Next. This is coefficient. It is an impact coefficient mostly used by the economists. They compare the economic situations of people. There is what is that developed countries, underdeveloped countries, developed countries, poor countries, also based on this coefficient. This coefficient is one of the instruments. Next, coming down the index, global index, all are economic parameters starting the economics parameter. Now, comparison based on index. Thing is that whether I can compare the standard index computed in one place, one situation with that of the other computed in different situations. So, in comparing these things, we need to have what are the variables we have compared. I am not talking about only standard index, by and large over the index, comparing the index, what are the variables, whether there is inequality in variable selection, variable comparison, Well, there is characteristics, characteristics. That means same variables are taken into consideration of a comparing indexes under two situations or more than two situations or not. That has to be taken into consideration. Well, elements of regular mechanism. The statistical tools what we are going to use, each and every statistical tools are perfect under certain regulatory conditions. Whether those regulatory conditions are being maintained in comparing your analysis, in comparing the indices, are going to be checked very accurately. Otherwise, the purpose of what we will be doing will be two points. Clustering, I was talking about this multivariate technique. We often go for clustering of the type. Clustering is, as I understand, is also used in bioinformatics sector quite different. I have given here the general idea of clustering. Gives us all. Clustering is a group of individuals and classes. Either they are similar or dissimilar. I used to give one example in classes when studying teaching the clustering. See, think about two antisocials. Will they never meet? Never. But two colleagues, they will come close together, they will discuss. So in clustering also, there are two techniques. Whether we are going to cluster the like-minded people or we are going to cluster, dissociate the unlike-minded. So two antisocials will come on two different clusters. This is the method, this is the idea. Okay? They are farthest neighbor and nearest neighbor, K and nearest neighbor, two coordinates. So the idea of nearest neighbor and farthest neighbor. Okay, so complete linkage and the simple linkage. See, so these are the process is that to work out the distance between the individual. Madam is sitting there, Madam Sir is sitting there. But how to measure the distances between those two? Because Madam is considering a number of characteristics and Sir is also considering a number of characteristics. Based on P characteristics, how the distance will be measured. So distance will be measured first, and then the distance will be measured in a number of people. So how we are matching which is the closest. That is the right. So what working out the distance and linking the individuals. Distance taking care of all the characteristics under consideration and how the linking of the individuals together. Next. So these are the some of the distance measures we have discussed. It was distance, square equivalent distance, square equivalent distance, then sitting of distance, divisor distance, hour distance, similar distance. So this is percentage estimate. Percentage in genetic analysis, in tissue culture analysis, the banding pattern or something, they will be taking cluster in banding patterns and similar, etc. The government distance in distance is a major breakthrough in statistical sciences which has been developed based on social sciences. Social sciences based on social characteristics, how the populations could be divided, population people could be grouped into different classes. So this is one of the distance. Next. Now amalgamation linkage. So there are three different linkages. Got it? Simple linkage and complete linkage. As I told you, whether we are going to have the two concepts together or two additions of two different together, that is simple linkage and complete linkage. Next. Now, whether we are going to give equal weightage to each and every character or not, that is unweighted pair two covalent, weighted pair equal to different weights, different to then it is weighted, otherwise it is unweighted equal. See, this is the example, one example. 20 varieties are taken and 90 characters are taken. How to group, classify? How do the classification changes or clustering changes with the change in distance measure, with the change in clustering technique or evaluation technique? See, these are the distance measures. Euclidean distance. Euclidean distance along this individual to individual. These are the square Euclidean. That distance what we have discussed. Then we do actually distance squared, including distance divided, distance not, distance, etc. etc. Next. So these are the distance matrix. Distance matrix. Next. Or distance column. Then percentage segment distance. Then now, using this distance matrix, we have tried to form cluster. And as I told you, there are two methods of linking. One is simple linking, another one is object linking. So, in the particular type of distance measure, that is this one is what is the equivalent distance, and using single linkage and complete linkage, how do we become? See, 1, 11 and 3. 1 and 11 and 3 in this complete linkage method and simple linkage method. So total picture changes as you change the one distance or linkage method with the same distance. With the same. Let us come to the next distance measure. So see, we have taken different distance measure. Different distance measure, but using simple linkage. There is a certain one. How do they change this? So my point is that you have to be very, very clear about your vision, about your objective, what you are going to do, how the clustering will going to help you in your objective, and accordingly break the distance measure. Not all the distance measure are equally applicable for every situation. The particular distance measure you have to fix depending on your situation. So study thoroughly about the pros and cons of the different distance measures and the pros and cons of the single linkage method and simple linkage method and complete linkage method, and then only you decide which distance measure is to be used and what type of linkage measure is to be used. Otherwise, you getting the varied range of clustering technique, and that may not be befitting to the objective of the suggested reading. I think I have come to the end of. Sorry, everybody, for patience hearing. I have taken a lot of time. Sorry. If you have any questions or time allowed, that is good. So just go on. Go on. These are the books I have mainly taken into consideration while framing this concept. Mostly written by our group, mostly. Right?